Hi, my name is Perry Spector, and today I'm going to tell you about Cereal Killer, an app I built to help people with food allergies quickly find breakfast cereals at the grocery store that are safe. This is Allison. Allison likes eating cereal for breakfast, but she also has a wheat allergy. When she's at the grocery store, it's really time consuming for her to sift through a bunch of boxes and find safe ones. Enter Cereal Killer. With this app, Allison can input her allergies, upload an image of multiple boxes, and the app annotates the image, color coding it for ones that are safe, unsafe, and ones that it's not sure about. So let's give it a whirl. This is the app deployed on AWS. Here, instead of a wheat allergy, let's say we're allergic to peanuts and tree nuts. We upload an image and run it. It takes about 15 seconds, so I preloaded this one. Given our peanut allergy, it indicates in red that Reese's Puffs is not safe because it contains peanut butter. These in green are indicated as safe, and these in yellow, the app isn't sure about. Even if it's not sure, it tries to provide useful information to the user. For Lucky Charms, it says safe if Lucky Charms, which is helpful for the user. So how does this work? The first step in creating this project was to train an object localization model. I didn't have a bunch of labeled training data to begin with, so I made my own. I scraped the web for cereal box covers, and then created images like this, where I took those box covers, applied projective transformations, and then superimposed them on scenes from the grocery store. These scenes look a little bit wonky, but I think that's an asset because the model learns that box covers can occur in a wide range of visual contexts. I used these images to fine-tune a pre-trained YOLO v3 object detection model to identify the locations of boxes. Now, when you give the model an actual image from the grocery store, it detects the location of boxes, and then the app crops those out for further processing. For each box, the next step is text recognition. And for this, I'm using the Google Cloud Vision API that returns a list of strings. For Corn Pops, the relevant strings are Kellogg's, Pops, and Corn. The next step is to use these strings for named entity recognition. And for this, I'm using a novel metric that I created that does string matching, but also accounts for font size. And so in this case, Pops would be the most important string because it's the biggest. The next step is to query a MySQL database of cereals and allergens that I created, and then to annotate the image, color coding it for ones that are safe, unsafe, and ones that the app isn't sure about. One of the technical challenges I encountered while creating this project was to ensure that the app never tells a user that a cereal is safe if it's actually not. These are the annotations from a previous iteration of my project. All the labels are actually correct, with the exception of this one in the bottom right, where Frosted Flakes is labeled as Corn Flakes. While this sort of performance for an object localization and classification model might be totally acceptable in a different context, here we're dealing with allergens and people's safety, and so this is not actually acceptable. So I went back to the drawing board and created a second verification step that if a box doesn't pass, it gets labeled in yellow, which indicates uncertainty. It also gets this if statement as a caveat. Here for Frosted Flakes, it says safe if cornflakes. If it actually was cornflakes, that would be useful information for the user. The overall point here is that I'm trying to communicate uncertainty to the user while at the same time providing them with the maximum amount of actionable information. So how well is the model doing? There are two relevant metrics here. The first is box detection, and for this I'm using a metric of intersection over union, which indicates how close are predicted bounding boxes to ground truth bounding boxes. On test data, I'm getting a mean intersection over union of 96%, which is pretty good. The second metric is for text recognition and string matching. For this, I'm getting a precision and recall greater than 99%. Now that number is really high, so let me put it into context. I don't mean to say that for every box that's detected, it is classifying the cereal correctly more than 99% of the time. But what I am saying is that for all the boxes that pass my stringent verification step, those are being classified correctly almost all the time. So now back to Allison. Equipped with Cereal Killer, she can quickly and safely find breakfast cereals at the grocery store. Thanks for your time. Again, my name is Perry Spector. I have a PhD in Earth and Space Sciences, studying Antarctic ice sheet change.